Okay, so today we are doing the first lesson of Probability of Simple Events 9.1. And just a reminder, probability is the chance something will occur. So we hear about probability a lot in the real world. We might hear, your chances or your odds of winning the lottery, or the chance of it raining on a certain day. So again, that's what probability is. It's kind of like predicting what will happen or what won't happen, and the percent or the chance of that happening. And part of probability, we have outcomes. Outcomes are a possible result in a probability experiment. So going back to that lottery example, the two outcomes would be either that you win the lottery or that you lose the lottery. If you're thinking about weather, an outcome could be that it rains or that it doesn't rain. So that's kind of the two key terms that we're going to be focusing on in this lesson. So to find the probability of an event, we want to make sure that we're using a ratio. Okay, remember that ratios compare two different things. So in this case, we're going to be comparing the number of outcomes of something that we want versus the number of possible outcomes. And the way that we denote probability is with the letter P, and then inside we write parentheses, whatever probability we're trying to find. So in this case, I'm going to write event to be generic, but if I was talking about the probability of finding out whether it's going to rain, I might write P parentheses rain and then close the parentheses. So the probability of our event occurring is always going to be, again, the number of favorable outcomes over the number of possible outcomes. And again, just a reminder that probability can either be shown as a fraction, as it looks right now, or you can turn that fraction into a decimal or a percent. So, for example, a real simple example, tossing a coin. So it says a coin is tossed. Find the probability of the coin landing on tails. Now you might know automatically what that probability is, but let's make sure we understand why and make sure we understand the correct notation. So again, we want to use our capital P, and inside our parentheses is going to be whatever event we're trying to make happen. So in this case, it's going to be the probability of landing on tails. Okay, the number of favorable outcomes is going to be the number of outcomes that would make this true. And the number of possible outcomes is going to be however many total different kinds of outcomes there are. I like to start with the number of possible outcomes and then look at the number of favorable outcomes. So in total, the two choices that there are when you flip a coin are tails or heads. There are no other choices, so there are no other outcomes. That means there are two possible outcomes. The number of favorable outcomes of getting a tails, well, there's only one way to get a tails when you flip a coin, because it's only on one side of the coin, is 1. So my probability would be 1 out of 2, or a half. Written as a decimal, this would be 0.5. And written as a percent, this would be 50%. That tells me that it is just as likely to get a tails as it is to get heads. I have a 50-50 chance. Another example that might take us a little bit further would be something like find the probability of rolling a 2 or a 5 on a number cube. Okay, so again, the type of probability that I'm looking for is a 2 or 5. That's my event that would make this probability true. So again, I want to write P, and there's my parentheses, so P of landing on a 2 or a 5. Now, most number cubes have 6 sides, and that means that there's 6 different numbers that you could land on. So my total number of possible outcomes are 6 different numbers, or 6. The number of favorable outcomes, in this case, is landing on a 2 or a 5. You can kind of think of some of these probability questions in the sense of winning a game or losing a game. So you can think about, if I was to win the game, I would have to land on a 2 or 5. How many different ways are there to do that? Well, I can land on the 2, or I can land on the 5. So there are 2 different ways of rolling a 2 or a 5, and my probability is 2 out of 6. Now remember that we do also want to always simplify our fractions. So I'm going to go ahead and divide the top and bottom by 2, and that would give me 1/3. So my probability of landing, or of rolling a 2 or a 5 on a number cube is 1/3. Again, we can figure out what this would look like as a decimal and as a percent if we need to. Taking it up one more kind of notch, we can talk about what happens when there's multiple options within the probability question. So for example, our probability question says, find the probability of choosing a red card. Okay, and maybe inside, wherever we're choosing this from, a bag or a deck of cards or something, the choice of choosing a red card, let's say there are 5 red cards and 8 blue cards and finally 7 green cards. So to find the probability of choosing the red card, again, we want to write P of red because that's what we're trying to find. To get the total number on the bottom, I would need to add up what my total number of cards is. Now, there's only 3 different options of colors, but if I'm sticking my hand in a bag, we have 5 red cards, 8 blue cards, and 7 green cards. So I would need to add all of those together to get my total number of outcomes. Okay, so 5 plus 8 plus 7 is going to be my total number of outcomes. The total number of favorable outcomes of choosing a red card is there's 5 different red cards in my bag. Okay, so out of 5. Kind of going through this and simplifying, my 5 is going to stay the same, and 5 plus 8 plus 7 gives me 20. So right now I have the probability of choosing a red card is 5 out of 20 cards. Now that's true, I have 5 red cards out of a total of 20, but again, because we're dealing with probability, we want to get this in the simplest form. So I'm going to go ahead and simplify by dividing by 5 to get 1/4. Okay, so you have 1/4 of a chance of choosing a red card. Again, as a decimal, we could look at this as 0.25, or as a percent, 25%. So maybe if this was a game and you were betting somebody or trying to win, and your option was to either pick red cards or to pick blue and green cards, you would probably want to go with blue and green because those are going to have higher probabilities. the probability, therefore, of choosing blue or green would be whatever my probability of red is minus 100. Okay, so my probability of blue or green, I don't even really have to do a whole lot of math, would be 75%. Because there's no other options, and probabilities are always out of 100%. So if I know that my probability of getting a red card again is 25%, then my probability of everything else, which in this case is blue or green, would have to be 100% minus the probability of my red, which is 75%.